All right, Unit 3, Day 4, rational exponent, ratios as the exponent. So a to the m over n. And this could be numbers, it could be letters, it doesn't matter. Right now we're just getting the vocabulary down. The top number is the power, the bottom number is the root. So flower power goes in the top, the root grows on the bottom. So that's how you keep it straight. The root's always the one on the bottom. The other way to write this, so there's the nth root of a to the m. So that means the same thing as this one. Those mean the same thing because they both have an m power and an n root. Another way to write this that doesn't look very different, but it's very different when it comes to evaluating these. For the first one we wrote, you would do the m power first and then do the root. But you could write this a different way and do the root first and then the power. Those are the same thing though, because they're both roots, or they're both exponents, I should say. So order of operations, it wouldn't matter. They're both exponents, so you can do the root or the power. It doesn't matter which one you do first, but usually we do the root first. Then power. And the reason is doing the root first gives us a smaller number. Usually, there's some exceptions, but usually doing the root first gets us to a smaller number, and then we power it back up to whatever. If you do it the other way, you power it up so you get a giant number, and then you got to take the root of a big number, and it's just harder. So same answer, but root first is usually the easier way. And that fits with our silly little flower analogy over here, right? The roots grow first, and then the flower pops up later. All right, we're going to do 3 things with these. So 3 Roman numerals. We're going to turn exponents into radicals. Then we're going to turn radicals into exponents. And then we're going to do some equations with exponents. And that follows exactly the worksheet in terms of the order of problems. All right, so 4 to the 3 halves. 4 to the 3 halves. Well, the top number is the power. The bottom number is the root. So this is the square root of 4 cubed. Right, most people, their brain processes roots better than fractional exponents, right? 4 to the 1/2. I don't know what that is. Square root of 4, I can do that. It's exactly the same thing, but sometimes it's helpful to write it this way. After you get the hang of it, you might not write it. You may just see, oh, that's the square root of 4, and then cube it. 2 cubed is 8. So that was the root first method. The power first method. So that's our preferred method. But if you really wanted to do the power first, you can do the power first. So that would be 4 cubed, and then take the square root of that. 4 cubed isn't nice, but it's not terrible. 4 times 4 is 16, times 4 is 64. And the square root of 4 is 8. So you get the same thing either way, it's just root first is usually the way to go because it gets you a smaller number, easier to deal with. In fact, I'm probably never going to do the power first again. That was an easy one to demonstrate that it works, but usually the numbers get too big to mess with. All right, 32 to the negative 2/5. Oh, here's a rule we might not have considered in a while. What's the negative exponent do? Do you remember? What's this mean? It flips it. So if it was in the bottom, it'd flip it to the top. If it's in the top, it flips it to the bottom. So a negative exponent flips the base. So it doesn't flip the exponent, it flips the base. So we'll flip the 32 into the bottom. And now we can worry about roots and powers. So the bottom number is the root. So the fifth root of 32, and then squared. Or I guess you could square 32 first, but I don't know what that would be. So again, root first makes your life a little easier. All the ones today are nice and integery. So you're not going to get, even though it looks like, fifth root of 32, I don't know what that is. Well, they're all integers, so if you think about them for a little bit, you can figure them out. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So 2 5 times is 32. That means the fifth root of 32 is 2. And then 2 squared is 4. So 1/4. Not a hard problem, but there were 3 pieces to handle there. There was a negative to flip it, a root, and a power. Right, 9 to the 6/4. 9 to the 6/4. So that's the fourth root of 9 and then to the 6th. But there's something we can do before that. What can we do before we start talking about roots and powers? We can reduce the 6/4. That'll make my life a whole lot easier. So let's reduce first so that, our regular math rules still apply. So that would be the square root of 9 cubed. So 3 cubed is 27. Some of you are going to get to the point where you don't show these intermediate steps. You're going to do those in your head and just look at that and say, well, the square root of 9 is 3, 3 cubed is 27, and write it down. And that's fine. That's fine. On the other hand, sometimes we give you stuff that looks like this. Negative 27 over 8 to the negative 1/3. It's like, well, we probably want to show some work on that one because that's a lot of stuff going on there. So the negative, again, flips the base. So I'm going to make that 8 over negative 27 to the 1/3. Right, so anything with the negative exponent flips over. Careful, anything without the negative exponent doesn't flip over. Sometimes people get a little ambitious with their flipping. Only stuff with a negative exponent flips. And then I can do 8 to the 1/3, negative 27 to the 1/3. 1/3. That means the third root, or the cube root. Cube root of 8, cube root of negative 27. So negative 2/3. All right, so exponents. Again, the only thing is the flower power grows on top, the root grows underneath. And do the root first because that makes your life easier. Now we can use that same thought process, but just in reverse. We'll go from radicals to exponents. So we'll start with some radicals and turn them into exponents. The fourth root of 7 squared. Well, it's like, what? I don't know what the fourth root of 7 is. That's not a nice answer. But the instructions are going to say something like, write each expression in exponent form. So let's turn that into an exponent. So it's still the flower power thing. The power grows on top, the root grows underneath. We're just using that in reverse. So the root is 4, so it goes on the bottom. The power is 2, it goes on the top. And so that would be 7 to the 1/2. Let's do one more of those. Let's do let's see, looking at the homework. They're all pretty easy. Let's do the third root of x to the 5th. And let's turn that into an exponent. So x, the power is 5, the root is 3, the root grows underneath, the flower power grows on top, so x to the 5/3. So it's the same stuff, just kind of using it in reverse. All right, lastly, some equations. So there's not really anything new to learn, it's just we're going to work some examples together. X to the 1/2 plus 9 equals 7. May as well say it now. For these equations, you need to check for extraneous solutions. Extraneous meaning algebraically they work when we solve the problem, but when we go to check them, they don't work. The good news is I looked on the test, and the test reminds you to check. So the big thing on these is just remembering to check. If you don't remember to check, you're going to forget and get some wrong answers. But if you'll read the directions on the test, which again is not something everyone does all the time, if you read the directions, they say remember to check. So it'll be, we don't want you to forget. We prompt you for it. All right, so let's get x to the 1/2 by itself first. Move the 9 over. 7 minus 9 is -2. And there's a couple ways to handle this. One way would be to convert that to a radical, but I think the easier way is to just leave it alone and raise it to a power to fix it. So how do you do a power to a power? Or I think I just gave away the answer I was trying to get to. When you have a power to a power, you multiply. So we're going to raise it to the reciprocal to get it back to just x, because power to a power, you multiply. A little alliteration there. Raise to the reciprocal. Reciprocal. That doesn't look right. I don't think I spelled that right. P-R-O? I don't know. Raise it to the reciprocal. That will, power to a power, you multiply. Half times 2 is 1. So that's what we wanted to do. We wanted just the power to be 1. And then the square of -2 is 4. But we've got to check all of these. And we check them back into the original. So 4 to the 1/2 plus 9 equals 7. 4 to the 1/2, that would be 2, because the square root of 4 is 2. 2 plus 9, wait a minute, that does not equal 7. So there are no solutions here. That's an example of why you have to check. Sometimes you get some that don't really work. If you're curious why they don't really work, which you don't have to be, it doesn't matter, you check them and you figure out whether it works or not. But when you square negative numbers, it wipes out the negatives, and that's where the problems come in. So you still got to check them to see, but if you start doing some of these, you may get to where you recognize, wait a minute, squaring a negative, that's going to be a problem later. Two times a minus 11 to the 5 halves equals 64. That was a little bit like one of the ones on the test. Wait, the test you're about to get back. Oh well. What do you want to do first on that? You can't distribute the 2 because this is to the 5 halves. So you'd have to exponent before you could multiply. So don't distribute the 2, but I do want to do something with the 2 to get rid of it. Let's divide by the 2. So a minus 11 to the 5 halves equals 32. We don't particularly like 5 halves, so we'll raise it to the reciprocal. Both sides, though, just like everything in math, whatever you do to one side, you got to do to the other. So this looks really bad, right? A minus 11 to the 5 halves to the 2/5, except the whole point of raising it to the reciprocal is that 5 halves times 2/5 is 1. And then 32 to the 2/5. That's the 5th root of 32 squared. Again, some of you will do that in your head. Others of you will write it as a radical. The 5th root of 32 is 2, and 2 squared is 4. So a equals 15. A equals 15, we think, I guess I should say, because we have to check. Although I didn't see any negative numbers in here, so I bet it's going to work. But, just to make sure. Let's see, 15 minus 11 is 4. 4 to the 5 halves. Well, again, the bottom number is the root. So the square root of 4 is 2. 2 to the 5th is 32. Times 2 is 64. So it worked. Yeah, the best news on that is that on the test it reminds you to check. So as long as we remind you, then you check and see if it works or not. Let's do one more. V to the 3 halves minus 4 equals 23. V to the 3 halves minus 4 equals 23. Well, add 4 to the other side. So 27. And then to fix the power, we raise it to the reciprocal. Raise to the reciprocal. So 2/3. And again, you show that to a younger sibling or something, and they're like, oh my gosh, that's impossible. How do you raise something to the 3 halves and then to the 2/3? That's crazy. Yeah, it looks bad, but the whole point is 3 halves times 2/3 just gets you back to 1. And then let's see, the cube root of 27 squared. Again, some of you are going to stop writing that. You're just going to do that in your head. The cube root of 27 is 3. 3 squared is 9. So we think our answer is 9. We always have to check. Although again, I didn't see very many negatives pop up in that, so I bet we're okay. But check it anyway. 9 to the 3 halves minus 4. So square root of 9 is 3. 3 cubed is 27. I did the shortcut that time. Didn't show my work. be careful on doing it that way without showing anything. So yeah, 9 worked, so we're okay with 9 as an answer. Again, check your answers, just to be careful. The worksheet I'm going to give you in a second. If you're watching online, worksheet's in the folder. And for you guys here or online, the answers to the worksheet are the second page of the worksheet in the folder. So it looks like there's only one thing posted, or only one worksheet posted, and I guess that's true, there's only one, but the second page of the worksheet is the answers. So you've got all the answers available. Answers online. While I'm here, the fraction worksheet from yesterday, the answers are online to that one as well in the appropriate folder.